You're rolling. Please stand. If you haven't, oh, you're all standing, never mind. Let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu in mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Okay, have a seat. Take out your practice tests, please. I'd like to go over that. For those of you watching at home, hi Greg. We will be posting this to YouTube. It's probably the only way you'll be seeing this, so that won't be a surprise to you. Yeah, I have a YouTube channel. There was actually a guy from India that subscribed to my YouTube channel, who, like one of my math videos for Algebra 2. And it's like,
How to turn.
how do you even know I exist?
What if he watches?
He wrote this comment saying, you know, very nice video, sir, or something like that. Are you
that's
kidding me,
fake.
or are you seriously from India? Yes, I am from India, sir, and it was a very good video. Thanks.
Sometimes they just need some help with math.
I guess. It's like, well, I mean, God bless him, but that really kind of weirded me out. Anyway, let's take a look. That was. All right. So, by the way, if you have any extra credit practice homework, feel free to turn that into the little metal shelf over there. I'm going to go through the test first, and then we'll go through the homework, the 1R after that. So take out your practice tests. They may not have them.
Wait, I don't know where.
I'm confused.
Yeah.
Can I use the bathroom?
You?
I'm sorry?
Can I use the bathroom?
Yes,
Oh,
go for it.
practice test.
And yes, anybody else not have a
Oh, wait.
copy of the practice test? It should say Chapter 1 practice test, 9th grade Algebra 1 on the top.
Yeah.
Problem number 1 is a term such as 8x to the 7th is made of 3 parts, blah, 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 blah. Okay, so first, grab your favorite red writing utensil. We're going to read out the answers first, and then I will go through any and all questions you have. I'll be a little more thorough than normal since we have a viewing audience at home. Here we go. Number 1. A term, such as 8x to the 7th, is made of 3 parts: coefficient, base, and exponent. Yeah?
Do those have to be in any order?
Not really, as long as you have all 3 of them. Any of those repeated or spell checked on any of
What
those?
about variable? Yeah,
Which one?
variable instead of exponent.
Oh, that'll have to, variable, I think you meant base. Because sometimes the base doesn't have to be, come on, what do you think, stick? You can have a non-variable as the base, for example, like that. So often it's a variable, but not always. So I'd have you put the word base there. So coefficient, base, exponent. Number 2, the answer is 32. Number 3, the answer is 34. If that doesn't match my answer, write in my answer. Run the practice test. Okay. So yeah, number 2 is 32. Number 3 is 34. Number 4, the answer is 5. Number 5, the answer is 104. 104. Number 6 is a fraction. The answer is negative 13 over 6. If you had negative 2 and 1/6, I'll accept it.
Negative 2 point.
Wait, what
You
was
did a decimal.
Do everything in decimal.
Negative 2.16 repeating. Now, if you're feeling exotic and want to do a decimal, you will need to know how to do repeating decimal notation.
Okay, cool.
If you round it off, the points of the problem will look like they've been through a war. So, beware. Yes, ma'am.
Can you please do this one because we had a
I
question
will.
about.
We're just going to go through the answers first, and I'll cycle back and do it. Number 7, fraction. The top is 70, the bottom is 81. Any repeats up to number 7?
What was number 7?
Number 7 was 70 over 81.
70 over 81.
Correct. It repeats. Again, I'll go over any of these you want after we get through all the answers. Next page, number 8. The shortest answer is 2 to the power of 6. 2 to the 6th power. If anybody has 64, that's legit. Oh yeah, yeah. 64 is technically a full term. It's kind of a weird full term. It's 1 times 64 to the first, which is, yeah, I suppose, but it's technically right. But basically anything that has a power of 5 or above, you don't have to simplify it, although you're welcome to. Number 9, 8 to the power of 8. Did anybody expand that out? Because it's huge. Okay. Good. Number 10, 8 to the 2nd power. You could also put 64. Number 11, 6 to the 3rd power. I'll even let it go with a power less than 3 if you want. 6 to the 3rd power is 216 if anybody calculated it out. Number 12 is 3 to the power of 17, which is enormous. Number 13, 3 to the power of 14. Number 14 is 4x to the 6th power. Number 15, 14x to the 12th power. And it repeats after number 15. Okay. Number 16, next page. It's a fraction. Last year. The top is 8n, the bottom is 3. You could also write it as 8 over 3 times n. Either way is fine. Yeah?
Right, sorry, what was number 16?
16 looks like this. 8n over 3. Or you could write it as, what am I doing? 8/3 n. Okay. Number 17 is a fraction. The top is 6. The bottom is 7r squared. You should not put the r squared on the side like this. That would actually be wrong. You could theoretically have put 6 over 7 times r to the -2, but that's a little on the weird side. And normally we like to get rid of negative powers. Number 18, 32 v to the 4th. 32 v to the 4th. Number 19, 16 a to the 19th. 16 a to the 19th power. And it repeats up to number 19. Okay. Number 20, x equals -2. Each of these should have a variable equals. Whenever you solve, it's a like x equals something or a equals something. Yeah.
Can you do plus or minus 2?
This particular one is just -2.
Okay.
Plus or minus shows up when you square root.
Oh yeah.
21, a equals -20. Number 22, m equals -8. Number 23, a equals 1. And it repeats so far. Next page, number 24, n equals -5. Number 25, n equals -16. Number 26, they just wanted you to translate this statement into math language. You did not have to solve it. Actually, you can't yet. It should be 5 parentheses x minus 7, close parentheses, minus 10. If anybody had 10 minus 5 parentheses x minus 7, I'd give you partial credit, but that's backwards and it would give you the opposite answer from what you need. Everybody go that far? 27. Translate this into an equation. 5 parentheses, 3 plus x, or x plus 3, close parentheses, equals 10. And it repeats. Yeah.
Just what is the what does it look like for number 26?
Number 26?
Yeah.
Yeah, okay. 26, what is with this number? 5 parentheses x minus 7, close parentheses minus 10. That's for number 26. Number 28. Should be the first term you can do two different ways. You could have 1/2 x, or x over 2. I put 1/2 x. Then after that, so it's, let me just write the whole thing. This is 1/2 x minus 3 equals 7. You could have x over 2 minus 3 equals 7. Both of them pretty much mean the same thing. This is the one that I would expect from the words that they used, 1/2 x minus 3 equals 7. But multiplying by a half is the same as dividing by the reciprocal, which is 2. Then solve it. The solution should be x equals 20. And it repeats up to 28. And we'll go over these in a moment. 29, now this is fun. You have a fraction. The top is x. The bottom is m minus n. And then to the right of it is greater than or equal to 15. Greater than or equal to 15. At least is greater than or equal to, yeah.
Is it okay instead of like putting it in a fraction if I just did x and then?
Divided by sign? If n minus n is in parentheses, yes.
It is.
Good. If they're not, then you'd actually get the wrong answer.
Okay.
Right, but that would work.
Okay.
Number 30. Is x equals 12 a solution? Yes, it is. Why or why not? Because if you plug in 12, you'll get 4 times 12 is 48, plus 2 is 50, which is less than 55. So if you show that work, good to go. Everybody good so far? All right, number 31. Between what 2 years was the greatest increase in the cost of a stamp? That would be from 1970 to 1975. Between what 2 years was the least increase in the cost of a stamp? There are several right answers here. You could go from 35 to 40, 1935 to 1940, 1940 to 1945, 1945 to 1950, 1950 to 1955. The cost of a stamp stayed this way. Anybody know what was happening in U.S. history right around that time? Yeah.
Which time period?
From 1935 to 1955.
Oh.
Yeah.
World War II.
World War II.
Korean War.
Korean War right at the end, yeah. And that's why the price of the stamp didn't go any higher. They had other things to worry about. C, what is the range of this graph? The difference between the lowest and the highest. I'll accept two different answers. You can either tell me it went from 2 to 10, or you can say that the range was 8. Either way, depending on your point of view, it would be fine. So yeah.
Could you do the 2 is less than or equal to C, which is less than or equal to 10?
Sure, yeah. If C is like the cost, yeah, you do a triple inequality, 2 less than or equal to C less than or equal to 10, correct. Number 32, what is the definition of a function? Choice A, 1 input yields 1 output. Just for letter B, all inputs are divided by 0. That's incredibly unhealthy, don't do that. That'll basically destroy everybody in a 90-mile radius. C, the answer to a division problem is quotient, and D, the answer to an addition problem is sum, but they're definitely not a function. Number 33, use the order of operations basically to simplify this. 33, the answer is negative 24. Number 34, it's a decimal, negative 32.4. 34, negative 32.4. And number 35 is a fraction, or a mixed number, depending on your point of view. If you did a fraction, it's 20 over 7. If you did a mixed number, it's 2 6/7. Yeah.
What if you did decimal?
6, for a 7? That's a 6-digit repeating decimal. Hang on, I don't even know what that is. Hang on. Okay, well, I think you have a future career in like the Navy SEALs or something if you enjoy pain this much. but you'll get 20 over 7, 7. 2.857142. So it looks like this. And you should have a repeat bar over those 6 digits.
Did you get it?
Mine was close. They probably used several digits for 6 over 7, so
Okay.
I just used one.
And that is it for the questions, answers, I mean. Repeats, last repeats, going once, twice, thrice. Okay, question.
For number 6, can
Number
you please do
6,
it? Because we
absolutely.
went through that one. The answer is super wrong.
Oh, okay. Let me look. Number 6 has the, oh, and forgive me, we killed this stuff. No offense. P minus 1 minus, is that number 6? Yeah. P minus 1 minus parentheses, P plus 1. Plus M over negative 3. And they tell us that M is 1/2. And P is negative 1. First thing I would do, actually there's 2 things you could start. It really doesn't much matter which one you do first. You could simplify this first, or you could plug in first. Either way works. Some people like to simplify first because having fractions in there first makes people nervous. I don't know why. But I'll do that. The negative sign here distributes. This is P minus 1 minus P minus 1 plus M over negative 3. And I'm going to massacre every single subtraction sign because I hate them with a passion, and they die, and that is a good thing. The P and the negative P cancel. You don't even have to plug it in.
Why does it cancel?
This is P plus negative P.
But isn't it a negative P to begin with?
Well, it's kind of like, well, P is negative 1, so what would negative negative 1 be?
Negative 2.
That's negative 1 plus negative 1. If I wrote it like this, negative negative 1, what's 2 negatives make?
Positive.
Yes, it makes a positive.
But why?
So this is positive B, positive 1. So negative negative 1, if you plugged it in, what does that really make? 1. And this is negative 1.
But it's a plus and negative.
This is plus and negative, but if P is already negative, it's plus negative, this is basically plus negative negative 1. These 2 negatives will cancel each other out and make positive. Make sense? And then that'll cancel this negative 1 here. So we've got negative 1 plus negative 1 is negative 2 plus this thingy, 1/2 divided by negative 3. Now this is a little tricky. How do you do a fraction divided by a whole number? Answer, you don't. You make the bottom a fraction. Dividing by a fraction is the same as multiplying by the reciprocal. So I can now do negative 2 plus, this becomes 1 over negative 6. So negative 2 plus negative a sixth is negative 2 and a sixth. Or, if you want, negative 13 over 6. Does that make sense? Any part of that you want to get? Yeah.
Oh, no, it's because you never said it.
Okay. 6 is okay? Yeah, question.
In decimals, that's negative 1, or negative 2 point.
Negative 2.166666.
Okay, cool.
Yeah, so if you did that, it would be negative 2.16 with the repeat bar over the 6, not over the 1. Does that make sense? Okay. Number 7, anyone? Okay. P over R, can somebody read that off for me? It's P over R in parentheses. And then what?
Parentheses, P to the 3rd minus R squared.
Okay.
Parentheses, P equals negative 2 over 3.
Oh, okay. Oh, that was the end. So P is negative 2/3. Okay.
And R equals 1.
And R equals 1. Oh, that's nice. So, let's try these. Could you simplify this? Yes. Could you try and distribute this? I'm not sure how simple that would be. You could. I'm just going to plug them in just because it looks a little easier. So 2/3 over 1.
Is it negative?
negative 2/3, thank you. Save my bacon there. And then this is negative 2/3 cubed minus 1 squared. All I did was plug in the plugins. There's gotta be a better word for that. In using parentheses. Question? Yeah, sure. Does it make any sense so far? All I did was plug them in and put parentheses around it. Now, what do I do first? Oh, math up, order of operations, remembering people. Say that 10 times fast. Tell you what, Catherine, take it.
What's in the parentheses first?
Yes, and if you have parentheses, 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 what do you do first? Which layer?
The innermost. parentheses.
Innermost, good. So I've got an inner parentheses here and an inner parentheses here. Do you do exponents or subtract first?
Exponent.
Exponents. How do you take an exponent to a fraction? Yeah.
Don't those cancel out?
Depends. If this is multiplied by 3, yes, it would, but this is a power. If it were 3 in front for multiply, yes, then multiply and divide would work, yeah.
It's not negative 2/3, it's negative 2/3.
Oh, same difference. I mean, that is a fair point. The negative can go anywhere you want, in front, top, or bottom, as long as there's only one of them. Because negative divided by a positive is negative. It would still be the same. So you don't have to put the negative here, you can put it in front, it'll be totally fine. But how do you raise a fraction to a power? Like, I'm gonna make one up. 2/7 squared. Any idea how to do that? Yeah.
Wouldn't it just be 2/7 times 2/7?
Right. In other words, it's 2 squared over 7 squared. You do them separately. So this particular one would be 4/49. That's just a sample. But this, can somebody do negative 2 times negative 2 times negative 2? Go.
Be positive, or no, negative 8.
Negative 8 over, and then 3 times 3 times 3. Ready? Veronica, take over. 27, good. Minus, what's 1 squared while we're at it? 1. Oh, and what's negative 2/3 divided by 1?
Negative 2/3.
Negative 2/3. It just sits there. Now then, how do we finish this problem? What do we do next? Yeah.
Would you multiply -1 by 27 to get 27 as the denominator?
Right. Gotta do parentheses first, and I can't yet without a common denominator.
And then you'll, wait.
So what common denominator do you think?
27.
27.
And then
So how many times bigger is that?
27.
27. What's the new top?
27.
27.
And
Nice.
then you can.
And by the way, guess what I'm going to do? Kill. So let me just rewrite this. So negative 2/3 times negative 8 over 27 plus negative 27 over 27. Should be able to add these now that they're a common denominator. Caroline, take over. What's negative 8 plus negative 27? Well, 27 plus.
Negative 35.
Very good. Negative 35 over what?
27.
Over 27. Nice. Finish it off for me. Go sit on the table. I'll show you why later on. The table in front is almost ready to meet its maker. So what's the top? Eric, go ahead. What's negative times negative, first of all?
Positive.
Positive.
It would
Positive.
be 70.
70 over,
81.
got it. That is right. Does that make sense? That was tedious. I'll be the one, that's probably one of the longest problems on the test. But just because it's so putsy, there's like a fraction plus a whole number, parentheses, parentheses, yada, yada, yada. But be very slow and methodical, you should have plenty of time. And, oh my goodness. Yeah,
I have
that was number 7, go ahead.
a question, concerning like any of them, but
Mhm.
for 8, for example,
Yeah,
with 2 to the 5th power, isn't that like a trick where you can do instead of multiplying everything by everything, can't you do
do like 2 times 2 is 4, and 2 times 2 is also 4, so wouldn't it be, if you multiply that, would it be 16 or would it be 8? Like, would you add it?
Which part are you talking about?
Like if you were to do 2 over 5 instead of going 2 times 2 times 2 times 2.
There would, the two over 5 means something else, that means a fraction.
Well, no.
But I think,
2 to the
you meant
fifth
something else.
x.
2 to the 5th power,
Yeah.
okay. 2 to the 5th power is 2 times 2 times 2 times 2 times 2.
So what if you had like 15 to the 3rd power and you did 15 times 15 is whatever 15 times 15 is? Or 15 times the
Then get the answer
5th
first.
power.
Gentlemen, I think you can settle or I'll have to separate you. We'll be stuck.
You had 15
Go.
to the 4th power and like 15 times 15 would be this. 15 times 15 would be that. Would you add those two or would you multiply those two?
Well, if you're talking about, this is 2 times 2 to the 5th power. What power does this 2 have? 1. So you can add these together and make 2 to the 6th power. And you can actually just
Yeah,
leave it.
but if you were going to write that all the way out, like if you
Oh.
were going to,
So 2 times 2 times 2 times 2 times 2 times 2. So there's 1 here and 5 here, so there's 6 total.
yes, but
Yeah.
if you were to find what that is, can't you do 2 times 2 is 4, right?
Okay.
And then you put like the little, yeah, and 2 times 2 is also 4,
This is also a 4.
and then the other one's also a 4.
So
And then
you,
would you multiply those or would you add?
yes, because there's a multiply in between. You basically did these, and these, and there's little multiplies left. Those haven't been used yet. So yeah, you still multiply those. So it'd be 4 times 4 is 16 times 4 is 64 if you did that.
Yeah.
Next. Yeah,
Can you do 12?
12, yeah. 3 times 3 to the 4th to the 4th. Eesh, I'm so looking forward. Yeah, I'll just do that, pretend I'm a waiter. So 3 times 3 to the 4th to the 4th. Okay, math people, what do you do when there's a power on power? What's the shortcut for that? Hang on a sec. Did we do it 10 minutes?
I don't know.
Oh, I did. Scared myself from that thing. Never mind. Anyway, Maddie, take over. What do you do with power and power? Multiply them. So what is this really? It's 3 times 3 to the what?
16.
Exactly. What power is the 3 here? Right. What do you do with these powers? Right. What's the final answer? Exactly. And that's what you can do leave. That wasn't even English. That's what you can, that's how you can leave it. I didn't know what I said. Is everybody good with that? Next. Yeah, good. 34. Let me look. Lost the page.
Skip that many.
31, 32, 33, 34. Yes, the decimal one. So 3.1 in parentheses minus parentheses 0.5 minus 8.2 close parentheses, close another parentheses, times negative 3. Here, I'm just going to go straight through, but I need to obey the order of operations. Just out of curiosity, did anybody distribute the negative? That is legitimate. You can do that if you want. What I did was I just killed the subtraction sign, killed the subtraction sign, and then I did the parentheses first. So I did this first. Negative 8.2 plus 0.5. One's positive, one's negative. They're going to fight each other. The negative is going to win by, I don't know, let's look. Negative parentheses, negative 7.7. So I'm just recopying everything. Look up here for a second. I just did the inside parentheses. Ta-da. Notice the negative negative. What does that become? Positive. So I'm going to switch that. 3.1 plus 7.7. This is the next parentheses I need to, what did I do? So 7.7 plus 3.1, I think that is 10.8. And then times negative 3. When you multiply a decimal, You can just multiply it by 3 and then throw the negative in afterward. I have no idea what that is. Let's find out. What am I doing? Brain, hand, get together. 10.8 times 3. 8 times 3 is 24. Carry the 2. 3 times 0 is 0 with the 2. 3 times 1 is 3. And then there's 1 decimal space I used, so I steal 1 back. 32.4, and then the final answer is what kind of number? Yeah, negative. So negative 32.4. Yeah.
Did you 33?
Does that make sense?
Yeah.
Any questions on that? I'm sorry, go ahead.
33.
33. Yeah, 16 minus 2 times 2. There's a little trickiness there. There's a temptation to do the 16 minus 2 first. 16 minus 2 times 2 over something, 4. I think that's multiplied to negative 4 times 2. Now, everybody look up here for a second. This is a visual. Whenever you have a fraction, and whenever you have a cluster, there are invisible parentheses around the top and around the bottom. They're treated like a group. The top of a fraction is always treated like a group. Bottom of a fraction is always treated like a group. So what would you do first? Kyle, take over. What would you do first?
You would multiply 2 and 2.
Exactly. In this parentheses, multiply comes before subtract. So what is it so far?
4.
Yeah, 16 minus 4 over 4
My bad, I missed that.
times, that's all right. Now what would you do next?
You would subtract 4 from 16.
Right. Even though the multiply is, I said, hey, I'm a multiply, I go before subtraction, there are invisible parentheses around here. So the parentheses go first. So what is that, by the way?
12.
12. Yeah. 12 over 4 times negative 4 times 2. Keep going.
You would divide 4.
Exactly. What do you get?
3.
3 times negative 4 times 2. And now with multiply, multiply, you just go straight across left to right. What's 3 times negative 4?
Negative 12.
Times 2?
Negative 24.
Got it. And questions on that? Go. Oh, no, get you next.
So here, why can't you do, originally, why can't you do 2 over 4, like the 2 over 4, why can't you reduce that to 1 over 2
Which one?
at the very top?
Oh, why can't you cancel this and this? Good question, because you'd have to cancel the 16 and 4 as well.
What about the
Because
far
everything's
right one?
divided. This one here?
No,
This one?
yeah.
Same difference. If you divide this term by 4, you gotta divide this term by 4 as well. So it'd basically be 4 minus 2. That would work. But basically, I'll show you a quick example. So you're kind of asking 16 minus 2 times 2 over 4. It looks a little like 16 minus 2x over 4. And some people are saying, can I cancel the 2 and the 4? Can I reduce it to 1 and 2? The answer is no, you can't. Because you're only canceling part of a problem. Dividing everything by 4 is dividing each one by 4. What you could do, I mean, it's kind of painful, but you could do this. 16 over 4 minus 2x over 4. You could divide each term by 4. That would actually work. 4 minus whatever that is, I don't know, x over 2. So you could do that here, but you have to cancel this. So it's 4 minus 2, which in this case would be 2. Which is, heck, actually, wait a minute. That cancels down, so this is 2. Oh, there's still a 2 here. Whatever, you get the idea. It's a little easier to do this first, because it's order of operations. Basically, if you're trying to cancel the top and bottom, here's an example I use with people. Hold on. Oh, I had a perfect example, darn it. Oh, yeah. 167 divided by 8. Does that reduce? Yeah.
Is it 20 and 7/8?
It is, well, that's not reducing, it's going into a mixed number. By the way, that's right. Does that reduce? Do the top and bottom reduce down? Like this 4/8 reduces. Like you shrink by 4 each, this becomes 1/2. That's reducing. Does this reduce? No. Well, what would you say to somebody, everybody look up here. I actually had somebody do this a long, long time ago at my first job. 8 and 16 reduced to 1 and 2, so this is 27/1, which is 27. That is horrible. Like, no, this is a disaster area. This is not even a normal, this is like a Mr. Yuck level, like bad. Don't you dare. You ever heard of the Mr. Yuck sticker, by the way? That was a big thing. It was actually a thing in the 80s, where to teach kids to stay away from poison at home, they gave parents Mr. Yuck stickers. Where like they had this symbol on it with a frowny face with a tongue sticking out. Wow. And then they would like be red or purple or something like that, and they would stick them on bottles of bleach or things like that around the house. So the kids who couldn't read yet say, "Now, Jimmy, look for the Mr. Yuck sticker and don't drink that because it'd be very bad." I don't know if they do it anymore, but they should. Anyway, Mr. Yuck lives in math problems, is what that is. But yeah, this is awful. The reason this doesn't work, this is not a 16. This is part of a bigger number. It's 167. You can't just cancel a piece of a number. Same thing here. You can't just cancel a piece of a number. You've got to cancel stuff from everything or nothing. So more on that later. Next. Yeah, I got it. Number what? 35. Oh yeah, that. 1/7/6 plus 2. First of all, it's a little hard to tell what's the fraction because the 1/7, if you take a magnifying glass, the line between the 1 and the 7 is a teeny bit longer, but it's so hard to tell you can't. So people might have thought it was 1/7 divided by 6, or it's 1/7/6. It actually is 1/7/6, like that. So dividing by a fraction is the same as multiplying by the reciprocal. So 1 times anything is just itself. 6/7 plus 2, if you want to be cheesy, it's 2 6/7. Or if you want to be elegant, it's 2 times 7 is 14, plus 6 is 20/7. Sorry, I'm slanting. Either way, it's fine. What I would ask you not to do, with mixed numbers, if you have like 5 and 11/7, people are like, wait, what? Like that's illegal. It's like, this is, no, you gotta fix that. This would be like, oh, what is it? It's like 1 4/7. What am I doing? So you can combine these to be 6 and 4/7. That's fine. But don't do a lopsided improper fraction with a number trying to make a weird mixed number. Yeah.
If we have like one like this on the test, will you make it like obvious which one is the fraction?
Which one is the fraction?
Yeah.
I will. I will either make it longer manually on the test, or I will tell you verbally.
Okay.
Yeah.
Can you do number 17?
17. Yeah. Let me see how much time we got. Yeah, I think we do it. 17. Yes. 17 is a bunch of exponents. Let me get rid of that yucky decimals. 6r to the 4th. This is number 17. 6r to the 4th over r to the 3rd, 7r to the 3rd. Now again, in a fraction, invisible parentheses around the top and around the bottom. I would do the bottom first. So I would do the bottom first. Now, how do you multiply r to the 3rd times 7r to the 3rd? Well, we like to do the numbers first, but I don't see a number here. Somebody tell me what it's 1. Do the 1 times 7. So 6r to the 4th over 1 times 7 is 7. And can somebody tell me r to the 3rd times r to the 3rd? Let me see. Go ahead. R to the 6th. Now does anybody see something reduce? Cal, take over.
The 4 and 6.
Yeah, how many R's are on top?
4,
How many on the bottom?
6,
How many R's will cancel?
2.
Sort of, kind of.
Oh,
There are 2 left. Yeah. 4 will cancel, and how many, the 2 that are left, are they on the top or on the bottom? They're on the bottom. Technically, this is 6 R, 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 7 R, 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 R. So 4 pairs of R's cancel, and 2 are left on the bottom. So it turns into 6 over 7 R squared. Please do not write this as 6/7 R squared. That is not correct. Because R squared by itself is bless you, it's technically over 1, which would put the R squared on top. So that would be illegal. Put it on the bottom. Does anybody write their fractions in with a slanty bar like this?
Sometimes.
Okay, I want to ask you to be aware of that. If you do, it's not totally illegal, but people might think, so is this 6 over 7R squared, or is it 6/7 R squared? It's kind of hard to tell. If you like slanty bars, the parentheses are on the bottom to make it absolutely clear. Okay. I want to make sure I know whether the R squared is on the bottom or not. And in this case, yes, it has to be. Good.
Can you do 19?
19. A cubed times 2a to the 4th to the 4th. So 19. A cubed parentheses 2a to the 4th to the 4th. Now the thing that will probably throw people on this, you see the 4th power on the outside? The 2 gets captured in that. This is 2a to the 4th times 2a to the 4th times 2a to the 4th times 2a to the 4th. So what it really is a cubed. And can somebody tell me what the power is for 2? Go. What's the exponent on 2? 1. What is power on power going to give you there? 2 to the what?
4.
Yes, and then a to the what? Is that the 4? Yeah, there you go. What is 2 to the 4th, math people? Anybody? Anybody? 16. 2 times 2 times 2 times 2. So put that out in front. We like numbers in front. And then how many total A's? Anybody? Go. Got it. A to the 19th, and that is your answer. Questions on that? Yeah, got about 10 minutes. Yeah.
For 18, then would the 3 get the 2?
Yeah, it'd be 2 to the 3rd, b to the 3rd. Correct. And 2 to the 3rd is 8. So, yeah. Next. Any others you want to see dissected? Now's a good time to ask. Everybody feeling comfy on that? Going once? Twice? Sure. Yeah, good. 7? I have no idea.
Yeah, we did.
We did. Oh darn, it was right in the middle there too. Yeah, there is. By the way, if you go on the YouTube, I will send an email home with the link to the YouTube channel for your parents. So if you want to check this out, this stuff you lucked out because Garrick needs the video. So if any of you want to look, I'll send the link to the YouTube channel, and this should be posted sometime, hopefully by 6 p.m. tonight. Yeah.
What's it called?
It was nothing fancy. It was like Mr. Coughlin's math or something like that. It's nothing really. It's not like you know, math channel of doom or something like that. It's getting. I honestly do not know. Now you got me curious. Hang on. YouTube. Okay. Your videos. Here I am. Channel content. It is called, yeah, it's called Brian Coughlin, so yeah, nobody's gonna lose me. I have a lot of videos on it from last year and the year before. I mean, if you get totally incredibly bored, if you have insomnia at like 2 in the morning or something like that, put on the headphones and watch the 9th grade videos. But anyway, yes, it is, for those of you listening at home, It is @Brian, B-R-I-A-N, that's my first name, by the way. Coughlin, C-O-U-G-H-L-I-N, 4802. So if you need to type that in manually, there's also like this 25-letter code thing for the YouTube channel. I'll email it home, you just click the link. And then I say, click like and subscribe, and you do not, if you click subscribe, you will actually get a notification whenever I post a new video on here, which is usually when somebody's sick, and if it's something really important like a Jeffrey test. If it's a normal sickness, usually I don't post this, but
You should.
yeah, trust me. It's, yeah. So any other questions on any of this stuff? All right, tell you what, you got about 6 minutes. You can go ahead and just, you can either finish the extra credit homework if you want. If you have the extra credit homework and it's done, turn it into the shelf there, the little metal shelf thingy. Oh, the homework thingy. Oh, fluffernutters, I forgot all about that. That, yeah. Tell you what. We don't have enough time to go through it. Rats. How am I gonna do that? How many people are gonna be taking the test tomorrow? Pretty much everybody except, okay, and you're gonna be CLTing. That's not a verb, but you know what I mean. And then vice versa on Wednesday. That means all you're gonna be taking CLT and you'll be here heroically taking the test. Okay. How about, it was just a review anyway, but well, I'll tell you what this. I will at least read off the answers. Does everybody have the homework with them? Yeah. Oh, we did not. We'll talk. There should be a way out. Oh, it's still in there. Yeah, please go. Save it from its untimely death. Let tell you what. How about I just read off the answers for you, at least, and then if you have any specific questions, we can go over it afterwards. You should be pretty much review. Oh my gracious. My dear sir. All right, we're looking for chapter review. Here we go. And sorry, Gary, I'm not trying to get really huge in the. My face is gonna look like it's about 3 feet wide. Give me my glasses. Here we go. For the review, they are as follows. Number 1, the answer is 37. Number 2, the answer is 18. By the way, no food in here, please. Oh, thank you. I'm blind for 5 seconds while people recover their law-abiding citizenness. Number 3 is 10. Number 4 is 2. Number 5 is 10. Number 6 is 4.5. Number 7, 2 hours. Number 8, 4,096. 4096. Number 9, 3125. Number 10, 2.25. Number 11 is 33. Number 12 is 32. Number 13 is a big number, 15,625. 15625. Just remember the 5 gets caught by the cube, so it's basically 125x cubed. Alrighty, next page. 14, the answer is 2. 15, the answer is 9. 16, the answer is 2. 17, the answer is 1.5.
Do you have that in fractions?
3 over 2, that'd be fine. Yeah. Or 1.5. Number 18, the answer is no. 19, the answer is yes. 20, the answer is no. 30, what am I saying? 21, the answer is yes. 22, write an equation and use mental math to solve. All you wanted is the final answer, 100 bottles. 100 bottles. You could set that up however you liked. Number 23, compare the number of titles won by US women, then with the number of US men. The women have won 41, while the men have won 30. Did they say 41? That's like, how did they know that just by looking at the graph? That was,
You mean
okay.
Wait, women won 41?
Yeah, they didn't even give you a number there. I don't know any human on the face of the earth who could look at that bar and say, oh, that's exactly 41.
Oh, that's what I said.
It could be 41 or 40. Okay, I know one person off the face of the earth who could do it. But they basically said the women won roughly 10 more than the other, than the
So
men.
you just read woman, okay.
For now, it's okay. They need to be specific in order for you to be specific. 24, find the total number of titles won by US men and women, compare. Roughly, men is roughly 55-ish, and women is roughly 80. If you were within 5 of that, I'll let it go.
Don't you like subtract those?
So compare it. So yeah, so I'll just say those are the two numbers. So about 25 apart, plus or minus. 20, 25, 30, somewhere in there. 25, make a line graph of the data. It should be a line that's going almost straight to the left. It goes straight, 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 and then down, up. Yeah, it's
You mean to
very,
the
very,
right?
very, very flat looking.
Really? Cause mine doesn't look flat. Mine doesn't look like that.
Oh, if you zoomed in, yeah. Is it kind of sort of flat in the first 3 dots, and then
Yeah,
goes
but I go
down,
by 2.
down, up, and then down? That should be fine. Yeah, depending on how zoomed in you got it. 26, what you can conclude from the line graph. The percent did not increase or decrease steadily. It just sort of wobbled a little bit. Is there any real data, like voting age population, pretty much stayed the same. A little bit of variation, but nothing substantial. 27, give me a verbal model. You could say P equals 10W. Or you could also say that Y is equal to 10X. Number 28, make an input-output table. The input should be 1, 2, 3, 4, 5. The output should be 10, 20, 30, 40, and 50. What's the domain? 1, 2, 3, 4, 5. The inputs. And don't. And then range is 10, 20, 30, 40, 50. Okay? As for questions, hang out of those. We are out of time. Tomorrow is test. Wednesday is test, depending on which test you're taking. Email me if you have any specific questions. Otherwise, I'll send you a link to the video. Oh yeah, we gotta talk about the video, by the way. We're going to deactivate the video, so Garrick, this is my hand waving goodbye. Talk to you later. Get well soon.